So now we're going to go ahead and try to actually answer these questions. So we know in the first one, they were asking for the y-intercept. So to answer how tall is the hill, we've got to think about, well, how do we find the y-intercept? And if I just look at the graph, there are no numbers shown here, so I've got to rely on my equation. So what do I have to do in my equation? Where do I have to look to find my y-intercept? So we need to look at the c value in the standard form of our equation. Right now, our equation is in standard form. We know that because it's the same thing as expanded form. If my equation had been in factored form, right, if it had looked like this, I would have had to expand it out in order to find this c value here. But luckily, it's already expanded out, and I already see my c value, and it's 80. So my answer is going to be 80 feet. Well, what about the x-intercepts, right? Well, in this scenario, when they ask us when the helicopter lands, we know we're looking for the x-intercept. But again, we can't really see it from the graph. So we're going to have to rely on the equation. How can we find the x-intercept or solutions from an equation? We have to find our zeros. That means we can factor and solve, or we can use the quadratic formula to help us. And we always want to start by trying to factor and solve. So that's what I'm going to do first. I'm going to see if this guy is factorable. And if not, I'll use the quadratic formula. So first thing I have to do is I have to put a number in for h. They're asking us when is it going to land, right? So what's the height when I land? The height is going to be 0, right? It's 0 feet off the ground once we've landed. So whenever they're asking for an ending point, remember we're going to replace that h, that dependent variable, with 0. And I'm just going to rewrite the rest of my equation here. Now we're going to try to factor. If I go ahead and try to multiply a times c to find my magic pair, these numbers are just a little too big. So what I'm going to try to do is find my greatest common factor. What's the biggest number I can divide all 3 of these values by? It's 16. But what I want to do is divide by a negative 16 so that this can cancel and become a positive 1 as my a value. So I'm going to divide by negative 16. And instead of pulling it out in front, I'm just going to divide both sides by that. 0 divided by negative 16 is going to be 0. On the other side, if I divide here, I'm going to get positive t squared. This guy's going to become negative 4t. And this guy's going to become negative 5. Now I'm going to try to find my magic pair. So I'm going to do 1 times negative 5. I'm going to list out my factor pairs. I could have 1 and negative 5. Or I could have negative 1 and positive 5. So which one's my magic pair? It's 1 and negative 5. And that's because I need to add to negative 4, not positive 4. So my bigger number has to be negative here. So I'm going to go ahead and split this up. I'm going to use positive 1t and negative 5t. And then I'm going to bring the rest down. Now I'm going to go ahead and try to factor this guy. So what should I factor out from the first half here? It's t. So if I take out a t, I'll be left with t plus 1. What about the other side? What should we factor out here? Negative 5. So negative 5 on the outside, and inside the negative 5s cancel, leaving me with t. Here, anything divided by itself leaves me with 1. So I need to show that plus 1. These guys match. That means we did a good job. Let's bring it up here and finish it up. So I have t plus 1 and t minus 5. I need to set those both equal to 0 and solve. So over here, I'll subtract 1. T equals negative 1. And here I'll add 5. T equals 5. So which one's our answer? Well, our time can't be negative, so it's got to be this guy here. What we have as our answer is going to be 5 hours.